first of all, why are we even talking about autonomous driving, right? So the number one reason why we want to talk about autonomous is safety, right? In fact, there is a I don't know how many of you know that Google, right, which now is Alphabet is the parent company. So under Alphabet, you have Google and so many other companies that talk about improving people's life, right? So one such company is Waymo. It was formerly called as Google self-driving car. So this is an extract from the Waymo report. So one of their studies actually said that 94% of all the accidents that has ever happened is because of a human error, right? And that's very significant. In fact, if you look at the number of people dying, about 1.2 million deaths worldwide due to vehicle crashes. And this was in 2013, right? And every year that number is constantly increasing, right? And that's not, it's not like accidents are common in India, right? It's common across the world. I don't know how many of you actually read about a bus accident that happened very recently somewhere near Coimbatore, where the driver probably felt as, slept off at about 3 o'clock in the morning, and this vehicle jumped onto another lane and crashed, and unnecessarily there were 25 people killed, right? And if you look at the statistics, every day people are dying, right? Today we talk about corona causing deaths, right? But if you actually look at it, people are dying every day across the world somewhere because of some injury, right? And if you look at the whole cumulative number, it's huge. So autonomous vehicle, the main proposition is that computers can do a better job. Algorithm can do a better job, right? Now, there's always a question of judgment, how better it is. We'll get into all those details, but safety is the number one reason why people are even talking about autonomous vehicles, right? It can make much better decisions than a human. At the same time, people are also talking about all the other aspects, including about $500 billion because of the loss of life and property and things like that, economic impact. And a lot of time is wasted in traffic, right? So if you actually look at the traffic part, the traffic happens because there is no proper communication between us, right? If you actually look at it, that too, especially in Bangalore, all this happens because of so much of confusion between vehicles and they're not able to communicate. But if you imagine a world, and this is proven, if you imagine a world of autonomous vehicles, these autonomous vehicles can interact with each other and then make optimal route planning, right? So there's the concept of traffic just doesn't exist, right? So it can accurately, sense what time you have to leave your house so that you reach your office at this time, and also what you do in between, right? Because the travel time is considered to be is significant, right? Especially if it is a traffic jam, you lose a lot of time. And people also talk about how you can be productive inside the vehicle, right? Since the vehicle is doing a job for you, you can maybe even take a nap in the vehicle. That's the vision what we have for autonomous vehicle. We never know, in 10 years from now how it will be, right? But I won't be surprised if all of us have an autonomous vehicle parked at our house, and I'm with a lot of certainty I can tell you that if you guys are fresh from college, maybe the first car that you buy will probably be an electric vehicle. It won't be a petrol engine, right? Because petrol engine or diesel engine has very limited, right? And also some other parts, some other points, including senior citizens not able to drive, people who have disability are not able to drive. An autonomous vehicle can actually help you do all that. That is all fine. But the key thing to understand is safety, number of hours wasted in the traffic light, and also the kind of economic impact that autonomous vehicle brings, right? So now moving into the next slide. So as I told, autonomous is not new, right? In fact, we have had stories in our Hindu mythology where we have had even sort of flying vehicles, right? So you can see here, somebody is trying to kidnap Sita, and it's a vehicle that can fly, and this is imagination, right? At the same time, we've heard stories about Aladdin and its magic carpet, or many popular cartoons or many of these sci-fi movies. I tried to put some movie names, but there are so many that I just could not know which to put. You can see several James Bond movies and all that. So we've been talking about this. In fact, the right side, what the image that you see is illustration by General Motors in the year 1950, around 1950, where you can see that a family is actually sitting and playing some board game, and the vehicle is doing the job by itself. So we have, as humans, right? We kind of dream about these things, but how to make it a reality? That's the difference between the dream and the reality, right? There's like a huge gap. How to make that? So it is, I would say that people have been dreaming about autonomous. I'm sure that if I ask you guys also will say, hey, I have that idea, I have this idea and all that, but how to make it reality is what we're going to see in the coming slides, right? So before we get into there, SAE, which is the Society of Automotive Engineers, which is a very well-respected body in the industry, they actually came up with 6 levels of autonomy, right? Basically, it's 5 levels. If you kind of leave the level 0, and they defined that there are possibly 6 levels of autonomy, and we will define the standard so that we understand what kind of an autonomous vehicle it is, right? So basically, the level 0 is the car that I have, probably a basic entry level car where there is no any autonomous features, where everything has to be done manually. In fact, I would say that maybe the ambassador car of the past, or a Maruti 800 car of the past, where even raising the windshield also, even raising the window is also quite a hand-driven job. So that could be a level 0 car, right? And then we move to level 1 car, in which these cars is having slight intelligence, which means that there is some features that it can do automatically, right? It could be like an automatic braking, right? Or it could be, maybe it can do a lane centering by itself automatically. And then there is level 2, in which there are more than one function, right? Actually, there's a very thin line between level 1 and level 2. And predominantly, the level 1 and level 2 is what is called as ADAS, right? Advanced Driver Assistant function. So ADAS is what drives, is what is level 1 and level 2. And ADAS is not new, right? In fact, many of the cars, what you see around you already have certain ADAS functions, right? A simple example is, some of the cars, when we actually put the reverse gear, it can actually sense how much of distance is there in the back, right? And basically, that's an ultrasonic sensor that is shooting out sound waves and capturing the time it takes to reflect. And based on that, it says, oh, this much is the distance. So that is ultrasonic sensor. So level 1, level 2 is already existing in the market, right? So then autonomous vehicle, the actual AD stuff comes, and by the way, autonomous driving is referred to as AD, and ADAS is autonomous driving assistance system, right? That is called as ADAS. So just a distinction between ADAS and AD. ADAS is not equal to AD, right? So when we talk about autonomous driving, AD, it is basically the level 3, level 4, and the level 5, right? And there are significant differences between these 3 levels. So if you look at the level 3, it is basically the car can handle driving by itself, and you don't have to monitor. But certain critical tasks, the car may need human intervention, right? So here you can see that, basically what we call it as eyes off, which means that your eyes need not be on the road. And a classic example of this may be cruise control, right? Where you're traveling on a highway, just like the picture over here, you're traveling on a highway, and let's say that you set your speed as 60 kmph. And then you are on the cruise control, and the vehicle will automatically maintain that speed of 60 kmph. Now, what happens if there is another vehicle that comes in front of you, right? Obviously, the speed needs to reduce, and it based on that distance, it will dynamically adjust the speed, which is actually more than cruise control. It's called as adaptive cruise control. So that is what is an example of a level 3. So level 4 is a little bit more advanced, where your hands can be off. You don't have to even be next to the steering. You can maybe sit in the back of the car and you can maybe work on your laptop, and you don't have to worry. So an example of this is maybe these kind of vehicles could be inside a certain constrained environment, right? As an example, let's say that it is inside an airport, right, where you have to ferry between the airport gate and the plane. So that is a known path. It's a constrained environment. So these level 4 vehicles can operate inside that, right? That's what is level 4. You don't need really too much of assistance for that. If you broadly look at it, the elevators, what we have in our shopping malls, they are also some sort of vehicle, because it lets, the definition of vehicle is you move from point A to point B. In the case of elevator or lift, the distance is vertical, but in the car, it is basically the vehicle with 4 wheels, right? So you see that, if you guys remember, in some of the now also it is there in some places, you have a lift operator who sits inside and presses the button. I always wonder why is that guy even having that job, right? Because we have advanced machines where, advanced algorithm where you just press the button and it can take you there. And that person who's sitting and operating the lift, that's a redundant job, right? So like that, in many of these redundant jobs, the L4 vehicle will take over and it can do its thing. But only constraint is it will be inside a restricted environment, right? You cannot take an L4 vehicle and say, okay, go in a highway, go in a city, go in an airport, go inside a school, go inside a campus. That's not going to happen. And then comes the level 5, which is the ultimate vision, right? And as I told, we are all dreamers and we need to dream big. The level 5 actually talks about your mind off, which means that it can travel in any environment, any region, any situation. It can handle day, night, rain, snow, city, urban, silkboard, Whitefield, anywhere it can operate. That's the level 5. And to get to level 5, it's not a normal journey, right? It's very, if you look at the first 3 levels, 0 to 1 to 2, we almost took 100 years or maybe 70 years to move from that point where we had hand gears to now even automatic transmission kind of vehicles. So right now, most companies are focused on the L3. And by the time we reach to L5, it's definitely going to take significant time. And there is where new skills are needed. With the existing skills, you cannot make this happen, right? And what are those skills? I will speak about that shortly. Moving to the next slide. If you look at the autonomous vehicle, basically, as I told you, it tries to mimic the human behavior, right? So the way, if we sit inside a car, our eyes see the road. So similarly, autonomous vehicle needs an eye, right? And cameras are the eyes for the autonomous vehicle. So, right. And it's not just one camera fitted on the vehicle, but rather multiple cameras, right? There could be 3 forward facing cameras. There could be 2 back rear facing cameras, 1 monocular camera just to look at the traffic lights, 1 camera to look at the driver behavior and things like that. So cameras are the eyes. So if you look at it, it's just trying to mimic your human behavior, right? So cameras are the eyes. Radar is yet another sensor that is used to identify what are the objects just near to it, right? So there is both short range radars as well as long range radars. And there is another sensor called as LiDAR, which is actually laser based radar, right? So LiDAR is light detection and ranging. So it basically, what it does is it's a rotating beam. You can see in this image here, like a bucket that keeps on rotating constantly, right? So what it does is it shoots a lot of invisible laser points across the surrounding, and it measures the distance that it takes for the laser light to go and come back, and based on that, it will tell where the different objects are. I'll just show you all this in an image very shortly. It will become more clear. So LiDAR is one important sensor that is used to understand the surrounding. Then obviously you have GPS. In fact, every phone has a GPS these days, right? Without which none of the things are possible. But it is not the GPS that we have in our phone that is used in an autonomous vehicle. These are military grade GPS, which can point to centimeter level accuracy, right? Sometimes have you noticed in your phone, when you order a food or something, obviously that guy will come and say, sir, I'm in your place, but where are you? You will say, no, I am here, come here, because your phone's GPS is not so powerful, right? It's a low cost GPS, right? And that's quite good enough for a phone, but for an autonomous vehicle, it's quite important to have good, very precise GPS, right? And there are multiple technologies that comes along with it, including something called as IMU, which is inertial measurement unit, and so on and so forth. Right? Then you have ultrasonic sensors. So basically, all these 5 sensors here form. It's trying to mimic the human behavior. We don't have a sound sensor for an autonomous vehicle, and that is something that people are talking about, right? So you think about it. Today, when we are driving, behind us, if there is an ambulance coming, how do you even know that there is an ambulance? It's only because we can hear, right? So it's quite important that an autonomous vehicle understands these kind of things, right? So when we actually do driving, we do billions of tasks, almost effortlessly, and that's the power of human intelligence. To make a machine do this, to make a algorithm do this, that's the challenge, right? And there is where the central computer, which is like the onboard compute unit, which is generally located at the back of the vehicle, that comes into place. And that is the one that processes all the input information, takes some decision, and then performs some action. Based on all these inputs, it understands what should be the next step. Basically, it's called the decision making. Then it does the path planning. Then it has to do localization, and then it has to do the control, right? And at the end of it, the control is just controlling steering, brake, and accelerator. It's just these 3 parameters that the vehicle is controlling, and that's what we also do as a human, right? And obviously, there's a communication module which is called as DSRC, and it can also have people are also having 5G networks that can enable it to talk to other vehicles, right? So basically, there's like a V2V interaction, vehicle to vehicle. There could be a vehicle to infrastructure interaction. For example, the vehicle can communicate to a nearby traffic light, for example, and understand and perceive that information, right? There could be a vehicle to person communication also. So all of these, whenever there is this communication or connectivity between vehicle and others, the connected part of the case area comes in. But as I told, we are going to more focus on the autonomous part because that's my area of focus. So moving to the next slide, before we go to this slide, I just want to maybe just show you a video which will make it somewhat clear. Roshan, can you confirm if my screen is visible, the video?
No, sir, it's not visible, sir. Your slide part is visible.
Just a moment. Is it visible now?
Yeah, sir.
Okay. So this is a video from NVDA, and I'll just play this. I'll not play the whole video, but certain bits of it. And there you can see an autonomous vehicle right next to this lady. So if you can see, what you're seeing on the top is essentially the LiDAR, right? It's a spinning LiDAR that is constantly shooting the laser beams. And this is a Ford vehicle. And you can see the number of cameras that is present on the vehicle, right? Almost like 1, 2, 3, 4, 5, 6, 7, 8, 9. And behind there are 2 cameras. And right at the center, you have the GPS and the IMU module. And around the vehicle, you see these black boxes fitted. Those are the radars. These are the different sensors that is there on the autonomous vehicle. And all these sensors, the goal is to get richer understanding about the environment so that the vehicle can take some decisions, right? So it needs to process, it needs to understand all this data, it needs to process, and then it needs to take some decisions. Now, coming back to the presentation, Roshan, is the presentation visible?
Yes, sir, your presentation is visible, sir.
Sure. So coming back to the presentation, so ultimately the goal of these sensors is, one is 360-degree environment sensing. Second is sensor fusion, which is combining all the inputs from these sensors to get richer understanding about the surrounding. And the third is to ensure that, irrespective of the weather, or irrespective of climate. Uh, for example, let's say that the autonomous vehicle with all these sensors is going, and suddenly there is a leaf that comes and covers the lidar, right? So if you just imagine here, let's say that there is a leaf or some cloth or something that come and obstruct the view, or let's say that it is snowing or it is raining, and because of that snow, the visibility, see this, the vehicle has wipers, right? But the camera lens doesn't have wiper, right? So sometimes what happens is some of these sensors can be obstructed, because of which there is limited view, right? Uh, and this autonomous vehicle, by the way, you cannot say that, oh, I'm only going to make an autonomous vehicle that's going to drive in daytime, right? The autonomous vehicle is, whether it is the day, night, raining, snowing, inside a tunnel, inside a place where there is no network, it has to work in all sorts of environment, right? That's what the cars are tested for. So it's if you look at it, it's a very challenging area, and it's along with the challenges comes the fun of doing certain things. So I will discuss some of the challenges, but it's quite important that there is a sensor redundancy, right? Which means that even if one of the sensors is not able to provide the data, the other sensors should be able to get the limited data and do some augmentation to that. So basically, in this diagram, you can see the autonomous vehicle and the kind of range it covers, right? So, for example, here you can see that there is a lidar, and it can almost cover about 150 meters, 200 meters, what is ahead of the vehicle, right? And these are very powerful lidars. Just to bring a point here, I don't know, about 2 weeks back, there was an Apple iPad Pro that was launched, and the iPad Pro actually has a lidar in it, right? So if you look at it, the purpose of that lidar is actually to understand the surrounding better when you're making certain augmented reality apps. And so those of you who are using iPhone, your Face ID technology is somewhat similar to lidar, but exactly it's not like lidar, right? So that's quite interesting about lidar, how lidar can play a very important role. And then you can see that it has one forward-looking camera, two peripheral cameras. There are some ultrasonic sensors fitted, which can detect how ultrasonic, by the way, is not very long range, right? It's about 6 to 8 meters in range. So this is mainly used when the vehicle is used when it comes for parking, or another vehicle is coming close, or if there is a pedestrian crossing, it can pick up the profile of the pedestrians and things like that. And then there is a surround view camera. There are radars, as I showed you. So all these sensors together are forming the human sensing system on the vehicle, right? So all this data that it is capturing needs to be collected, it needs to be stored, it needs to be processed, and that processed data, some decisions have to be taken, right? And then the vehicle will move. It's not just like autonomous vehicle, automatically moves, right? This is not like a remote controlled car. So I just want to switch back to the video for a moment and show you exactly, how the autonomous vehicle sees the world, right? So if you look at this screen here, you can see that there are so many information that the autonomous vehicle is capturing, including the different traffic lights, what is the state of the traffic light, whether it is on, whether it is red or green or yellow, and how many pedestrians are there, and so all those information is captured here.